discussion, and let's see if we can move this microphone over to you guys. Not sure if that's going to work or not, but yeah, in case you feel like you want to use it.
Well, I'm Wendy McCart, and we're going to start with about 10 minutes of just questions for these guys based on their talks, and then we'll open it up to a more general discussion. So any questions about any of the talks? Diverse and varied. Yes?
I kind of felt like I might need to solve the machine intelligence problem to come up with a good hint to give a user to help my system debug itself. And I'm wondering, is there a sort of an infinite regress thing in there about if you have to have a system that understands itself deeply enough to know what hint to give a user to teach it? I don't know, just take that away.
So actually, work, we try to define mathematically what does it mean a good hint. And for some cases, for some algorithm, we can actually explicitly solve this. It end up being an optimization problem, and you can actually find the optimal hint. However, for more sophisticated models like trees or neural nets, this is actually hard to do. And not only that, you want this debugging process to be interactive. So even if I can solve it and it's going to take a lot of time to find a good hint, it wouldn't serve the interactive process of really debugging. So we have ways of approximating these methods, and they're pretty generic. So they can work, we've already got them working for linear model, Gaussian processes, and symbols of trees, neural nets. So pretty wide variety of algorithms that we already know how to give hints for. Although I would say, especially in this audience, we didn't do the usability study yet of trying to see how it works with user. We have these anecdotal cases. We were focusing, I have to kind of reveal my secret that I'm coming more from the machine learning side of studies. So we looked at that aspect, and there are some studies that are already done, kind of comparing different ways of debugging, and they were asking, if I could come up with an textual explanation, would you prefer that over if I could, say, come up with a hint? The problem that we're looking at is, can we find this explanation that you can use, such that we can try it with users?
Do any of you want to answer that question? Because I think you would take different approaches than this one. So we would take a different approach.
Well, the hint for me wouldn't work quite the same, because I think you're talking more about this, you have training examples, and we don't have that for topic modeling. So in my case, that the hint of where your model went wrong is we can show you the topic in the documents and you can modify it, but we can't point to exact training examples or something that caused your issue. So have you thought about that sort of side of it?
We didn't look at the topic modeling, but I'm not sure that it's you cannot just try to find the small subset in your training data that will demonstrate the same kind of prediction that the model does, and try to show it to the user. For example, if your algorithm did not pick up that these two words are actually a phrase and they should be treated together, but looking at a few examples next to each other, it's easy to pick it up. So we didn't look explicitly at how to find hints for topic modeling, but I'm not sure that it's impossible.
Hold that there. Other questions about topics? Yes.
So what I found quite interesting was that obviously there's various ways to interact with machine learning algorithms. So perhaps showing a subset of the training data, perhaps through visualizations, and perhaps you as a kind of talk a little bit more about, where do you feel like, sort of new challenges within that line. Should you actually just say, well, interacting with the data set is the best thing since sliced bread, let's just go down that way, or, visualization, it's great, let's go for that, but also perhaps explore some of the nuances within what you actually
I could, yeah, I think so. I think the question of what type of interaction we should encourage and continue to improve comes down to what data we're working with. So to me, the goals of these systems should be to support whatever. So I come from a data analysis perspective, so I'm always thinking about it in terms of solving some data problem. But solve some user problem or data problem, you have to take into account what you're actually trying to get someone to do and what you're trying to help them with. So I think the key is not to necessarily just develop techniques with an eye towards this connection between viz and machine learning, but to build the tools towards the actual goal as always, and then just make sure that you can collect what you need to make this loop work.
I saw a hand over there, but there's a hand here, so you can.
So I guess this is kind of a variant of Simone's questions. I noticed a lot of you talked about challenges, principles, and I think, maybe I can direct this to you, like this about like the framework that you present, right? So the thing I like about frameworks in general is that sort of they help organize sort of the work that we're doing. But I think another benefit is that it can sort of contrast user interaction with machine learning with sort of traditional HCI and user interaction with computing systems that don't involve. I think the difference there is it doesn't have an algorithm. Traditional interfaces don't necessarily have like a statistical model that's sort of unpredictable. I think that was one of the principles that came up. It doesn't have the data. It's not being driven by a large set of data that you can't really look at all at once, so you have to summarize it. And so I think being able to contrast what we do here with like what we do in traditional HCI might help reveal some of the challenges and principles for designing these systems. So just maybe want to open that up to the panel to see.
I think we're opening up to the more general discussion, so that's good. So you guys get a chance. I'm going to take a step. And I'll get you guys first.
Just want to add another dimension to what said here. So obviously, on one hand, we want to find some principled way that work across the domain, but at the same time, it's not one size fits all. So sometimes we have to tailor it towards something. And one dimension which is interesting is to look at big data versus small data. So big data is a big hype now and everything, and it looks very different than the scenario when you have actually a small amount of data, or actually none at all, and you want to start just building it up. And I think that the kind of interactions that you expect and the kind of importance of different types of interaction is very different when you work in each one of these. And we need not forget about small data, although the hype is around big data.
Yeah, and I have, just with the interaction, I think I like being able to organize in the framework, like you said, but I also think it's important that we remember that there's also this spectrum of interaction. It's all based on the motivation of your user. We don't want to just say your only option is directly manipulating this. So for example, with Netflix, they're going to take into account the fact that you watched the movie, the fact that you rated the movie, the fact that you clicked on it and didn't watch it, and all of that's going to go into it. So we want to make sure we're taking advantage of all of the possible interactions with what we're creating.
I was going to say another thing based on what you were saying is that there's a really, I think, interesting difference in who the audience is for these algorithms. And if you come from a machine learning perspective, you talk about the human in the loop. And the human is there to help you fix your algorithm, basically. The HCI perspective is what I like to call the computer in the loop. And the algorithm is there to help the user do something else. And so those don't have to be in conflict, but they often are, because if you don't challenge that assumption from the beginning and say, well, what am I trying to accomplish here? You can get lost and end up doing things that somebody who's on the other side might not understand. So I completely agree with you that doing some kind of taxonomy and sort of sorting out some of these different things is really useful, just so that we're talking the same terms and we understand what our goals are at what time.
Yeah,
Go ahead.
I hadn't thought of, I like that too, because I hadn't thought about the fact that one useful part of such a framework is to say, what is this here, right? What are we not talking about when we discuss this?
Other comments, suggestions, questions? We're looking at see, what are we doing? We're doing HCI methodology and how that can affect machine learning and how do we think about those together? Throw that out to you. Yes.
I have a question about the LDA stuff. Why do we want users to change the topics? Like, what's the final goal in line with this idea of helping the user do something?
Great. So in our cases, we're thinking about users that have domain knowledge they might be able to bring into the model. So being able to pull together words that belong together. Or another example I didn't go into is we have users that, we're working with some analysts that were looking over all of the documents that were different abstracts from NIH, and they wanted to be able to organize based on the different types of technologies people were talking about. And we were seeing some grouping into topics that wasn't appropriate. So by letting the users sort of split the topics into two technologies may have gotten grouped together and they wanted to split them separately, that kind of building that intuition into the model is really useful. I didn't go into this, but another really important thing is, again, I would really like to come back to how motivated your user is. It's not really usually going to be the case that we're going to sit someone down with this model and say, okay, add words here and remove words here. There's going to be this abstraction layer, like possibly we just are working over users that have put their documents into a folder structure, and we can train a model behind the scenes on the folders as they drag things around or say things don't belong in my folders, then we're updating the model. So it's really coming down to your application, how into the deep end you want to put your user and how into the deep end your user wants to go.
Yes.
Have you tried in your research to think about other ways to visualize, to display the information from the model in the data rather than just visualization? I mean, just, sound, other ways to display the information from the machine learning.
Okay, yes. So this sounds quite hard. So first, it's kind of like a trade-off thing. So in order to, first, we use a machine learning algorithm. Definitely we want the user to understand what the machine learning shows to us, right? So that might be one go. So we show these things, like the search things. So first, if that perfectly matched what the user wants, then the user might be able to, the task is done. So the algorithm actually shows me something. Then another case shows up. So what about if the algorithm result is kind of like different, a little bit different, or maybe much more unexpected than what you would think. So from my personal opinion, it kind of like, so in two cases, so if it is totally different, so the user might be, okay, that is not useful, that is not what I want. But let's think about flip the side of the coin. So if that is quite different from the user might also think about something like, oh, I never think about these things this way. It might trigger me to think about, okay, possibly my original thinking might be wrong or might be different. So that is kind of like a side effect about the difference between what a machine learning shows to you match what a user expects. So it's kind of like hard. So we try to take an approach kind of like we show the result to the user and allow the user to make decisions. So definitely, some kinds of machine learning algorithm always gives you a whole maybe a long list of reasons. So definitely, we have to prioritize those kind of stuff. Maybe the top 5, top 10, like you typing in the Google search, you got the top 10 result, possibly based on what you searched previously. And machine learning, you try to guess what you want. It's kind of like, we really want to inject a human brain's shape to the machine learning and try to change the machine, kind of like equip the shape of the human, or we take some ways to train the human, think about like doing things like a machine ways. So it's like two-sided things. We either want to get in from the machine side or from the user side.
Yes.
I have a question that's somewhat connected to this whole topic. We talked a lot about guided exploration. There's a context in like the requires exploration on the other hand, in such sensitive contexts, actually.
Okay, so, yes. So that would be, so to guide a user comes from the problem like the data grows fast, the machine learning always gives us lots of results. So our work tries to, so actually as I showed here, like the user seems like mouse around something, it prioritizes who down show. In the example is particular byte clusters. So actually, so our work there, so it's still under review, is the machine learning algorithm actually take the information from the particular byte cluster that the user actually interacted with and send that part of the information to a different kind of machine learning algorithm. And that algorithm try to perceive since the user actually interacted with this thing. So the machine algorithm potentially think that, okay, user might know something about this particular thing there, then we can try to figure out maybe related ones, related with this ones, and try to prioritize those things. So after next time, the user actually see mouse over the first one and mouse over the third one. Then the next time, the machine learning kind of try to progressively understand, okay, user previously know that one, and this time they also know the third one. Then we add up what the user have already known, and then adaptively to show the result of the second time evaluation, like the second time prioritization thing. Yeah.
Do any of you ever, I'll get back to you, but do any of you ever reveal an aspect of how you came to the decision? Because users over time change what they want. There isn't one fixed point in time, there is this correct answer, but rather, at this point in time, I'm searching for a trip to San Jose. Next week, I really don't want lots of hotel suggestions for San Jose. It's just too late. And so the question is, how does a user interact with your systems to find out how you decided what they should be getting, which gets back to what you're talking about, because if you're in a sensitive situation, you want to be able to know that the fact that your kid was online last week and did something that is now going to flag something with the police over there, that you would like to know that that's what's causing the problem. So any of you, and then I'll get back to it.
I just want to twist a little bit what you asked, and that's kind of, it's an interesting topic of the ethics of machine learning. Because, if you take the example, take the example of, say, police work, and they, get all sorts of alerts and now they interpret or them. They can say, I'll train on historic data. But if historically they had, for example, racial biases, the learning algorithm will have racial biases, right? They will learn that if the person is, say, a person of color, oh, this is a suspect, versus if he's a Caucasian, it is not. And that's so there are solutions to that in machine learning, but there are actually, the proper ways are just impossible to use. So it will say, okay, in order to train a machine learning model which not going to have racial biases, you should just go at random to people and check whether they're, just go out in the streets, go randomly to people and just arrest them just to see if they are involved in some criminal work or not. And we started to look at that. How do you do that in a way which is feasible? It's a hard problem, and it's a very interesting one, and we should pay attention to it.
Probably some HCI methods that would help inform that discussion, so don't start from scratch.
So in terms of keeping the user engaged with how the model is developing, I think that is one of the really useful things about choosing machine learning methodologies that produce comprehensible models. Because if you produce models at the end that are human readable, you can also show the user those models as they build them. So in the dysfunction example that I gave, they're learning a weight for each of the different data dimensions that shows its relative importance to their investigation, and we actually can visualize as they interact with the data how the model is changing. Excuse me. And I was going to say something else. I guess that was the most important part.
I'll stick with that.
Yeah, I mean, I think this is really important from the idea of trust. So like we talked about with the hints, then you can give with when someone's using the interface or they find a classification and they want to understand, well, why was it? Trust is really important, and that links again to motivation, my favorite one. Because, for example, like Google News, they've started recommending news articles to you, but they'll tell you why. You're getting this because you read this article. And so if you get one that doesn't make sense, but then explains to you, then you're going to trust it better. If you get one that doesn't make sense without an explanation, you might just stop using it. So it's really important.
Okay. If you remember your question.
No, they had such great discussion. But one of the things, and this understandable models thing, and coming back, we already know that people who are not technically savvy, you basically are given an all or nothing kind of trust model, where it's like, I either trust the computer because it's the computer, or I don't trust the computer because it's the computer. And I wonder, I feel like a lot of the stuff that probably we all produce works on an assumption that the user is going to be someone with at least a bachelor's degree in computer science. And that's what we think of as the naive user of machine learning.
I think everyone has a bachelor's degree in computer science, right? Let's hold the poll.
Yeah, let's do a sample now.
Right, it's a sample, right? It's a fair.
And I just wonder if you guys or anyone in the room has been thinking about this other aspect, which is teaching users who, as we hope, our machine learning algorithms will spread to wider and wider sets of users, and the interactive paradigms will spread to wider and wider sets of users. How do you educate them so that they can make reasoned, like what the heck is a topic model? I don't know, it's a bunch of words. What does that even mean?
Well, so
What is a linear regressor? I don't know.
do we want them to have to understand, or do we want to communicate the results so that they don't have to understand how it is done?
Ideally, I think I would like that, but coming back to his point, if we're talking about law enforcement agents and eventual criminal prosecutions of people based on an interactive machine learning thing that spiraled down to what do you want to call it, a local minimum, which isn't a terrorist, but happened to be 3 teenagers plotting a major Halo playing session that involved slaying many bad guys. I don't know, but
If you want to jump in, we can discuss.
So my research actually focused exactly on end users without computer science education whatsoever, trying to understand machine learning systems. And this isn't, I actually really agree that I think there are a lot of cases where maybe we don't necessarily want them to understand the algorithm whatsoever. There are different ways to explain that. But one of our big findings was that people are remarkably able to understand that if you present it in terms that map to the domain that they're working in, things that are familiar to them. But you can go surprisingly deep with those explanations, and you're not getting into necessarily the jargon of machine learning, but you're visualizing things in a way that makes sense. You're showing, like if it's a spam filter, you're showing the specific email messages that it's paying attention to the most, the words it's paying attention to the most, how those ratios are playing out, things like that, with a lot of success.
And one example where this really matters is the medical domain. So doctors have, they believe, for better or worse, that they know everything, even though they don't have a computer science background, they have a technical background. And so they really don't trust computers. And that may be good because we would like our diagnosis to come from a person, but there's a whole kind of field of computer-aided diagnosis and similar things where you try to use a machine learning tool not to just say, oh, this is benign or malignant, but rather show the physician the appropriate examples so that the decision still comes from them, but they're being guided by the best possible information.
I think the last one there, Mr. had his hand up, but last one because we're out of time. Yeah, sorry.
Just touching on the law enforcement thing and then on the medical, you have to remember that the domain-specific knowledge that the user has might actually be some strange illogical bias that something they believe that is actually not true. And so our worst-case scenario in the context of human machine learning, in the law enforcement context, is actually that the model is coerced into using some dimension that actually just proves that someone's guilty of something. So this is the argument for dog is actually really good at just reading the prejudice of the handler and some contraband. So I think I mean, I think we've already been touching on this issue, which is that the user should be made aware of how they're affecting the model and how, if there is conflict, to what extent, how they maybe, how their interaction is affecting the changes in the model. So they could be aware, okay, I think a doctor could do this as well. They have some particular weird belief about, everyone has a certain disease or something, that they could be aware that, okay, it looks like I'm actually kind of pushing this too far. That the data alone was not really going to support this prediction without me really pushing it.
Okay, I think we stop there. Thank you very much for
So there are coffee and snacks out there somewhere. We'd like to start up with the next set of speakers at 11 o'clock.